Hey everyone, and welcome to today's Explainer. We are going to be exploring something incredibly critical, but largely invisible. I'm talking about the vast gas infrastructure buried quite literally right beneath our feet. We're going to dig into the network of pipelines that deliver our energy, and more importantly, we'll unpack exactly how operators track their vulnerabilities and ensure our safety. It is this fascinating, high-stakes balancing act of engineering, finance, and risk management.
Okay, let's jump right in. We really need to confront the reality of this aging infrastructure because the stakes are astronomical. Gas leaks, they aren't just an inconvenience, they are incredibly dangerous. Managing this massive network requires some serious long-term vision, mainly because the consequences of failure are just so high, especially when we're talking about densely populated urban areas. So, what exactly happens when these pipes get old, and how do companies even keep track of it all?
Well, when infrastructure fails, we're basically looking at two major nightmare scenarios. First, you have the immediate, absolutely terrifying safety risks. Losses of containment that can trigger fires, massive explosions, and tragic consequences for human health. Then, on the flip side, you have the severe environmental risks. Even if a leak doesn't ignite, it's still pumping fugitive emissions, mostly methane, straight into the atmosphere, which creates some major, long-term climate impacts.
So how do we actually measure the integrity of a system this huge without just guessing? Well, sustainability accounting standards require what we call a dual-lens approach to measure the risk. Utilities essentially have to track their passive vulnerabilities, the physical pipes just sitting in the ground, and then contrast that with their proactive measures. It's a pretty brilliant way to balance identifying what might break while simultaneously proving you are actively out there looking for the breaks.
Quick baseline here before we get into the heavy metrics. It's super important to understand the framework we're dealing with. The SASB standards, which are now managed by the International Sustainability Standards Board, actually mandate exactly how gas utilities have to disclose the health of their infrastructure. So we're not talking about arbitrary numbers. These are highly specific, rigorous sustainability accounting standards.
All right, let's start with lens number one. This focuses on the reactive vulnerability of the network. I like to think of this as checking a patient's family history for a genetic predisposition to a disease. Certain materials that were used to build these pipelines decades ago are just inherently more likely to fail as they get older. So by tracking exactly how much of the network is made out of these specific materials, we get a really clear picture of the baseline risk a utility is carrying.
And that brings us to metric IFGU 540A.2. This specific metric forces utilities to disclose the percentage by length of their distribution pipelines that are made of two highly problematic materials. Let's actually break down what these two vulnerable materials are, because it's pretty eye-opening.
First up, we have cast or wrought iron. The standard defines this as iron that's been heated to its melting point and poured into molds, which means it literally cannot be molded further or screwed together. Because of this really rigid manufacturing process, the older material is super brittle and totally vulnerable to shifting soil as it ages. It is a massive red flag for corrosion and catastrophic leaks, which is exactly why investors and regulators demand to know exactly how much of a utility's network is still relying on the stuff.
Second, the standard isolates unprotected steel. And yeah, it is exactly what it sounds like. Steel completely lacking any corrosion protection. Putting bare steel into a damp underground environment is basically starting a ticking clock on rust and decay. By forcing utilities to report the precise percentage of their local lines made from cast iron or unprotected steel, we get a quantifiable look at their baseline risk for devastating leaks.
Okay, let's switch gears to our second lens and see how this builds out the rest of the picture. We're moving away from the passive, genetic risks of the materials just sitting there and moving toward active, preventative healthcare for the pipelines. Because honestly, knowing what the pipes are made of is only half the battle. The other half is knowing what the utility is actually doing to monitor them before a disaster strikes.
Directly contrasting that material-based metric we just talked about, we have metric IFGU 540A.3. This one is all about proactivity. It tracks the exact percentage of the network that was actually inspected during the reporting year. But notice a really key difference here. It requires utilities to report on both transmission and distribution lines separately.
Unlike the materials metric, which really only cares about your local distribution, this inspection metric holds utilities accountable for the entire grid. That includes the massive transmission pipelines operating at insanely high pressures, technically defined as a hoop stress of 20% or more of the pipe's specified minimum yield strength. Inspecting both the local and the long-distance ends of the system is absolutely crucial.
And the standard is wildly specific about what actually counts as a legitimate inspection. A guy just walking over the pipe with a clipboard?
Not going to cut it. Utilities have to use advanced internal inspection tools that physically travel inside the pipe to find corrosion. They've got to run high-stress pressure tests or perform direct assessments that specifically hunt for external corrosion, internal corrosion, or stress cracking. They literally have to sniff out hidden threats using rigorous, proven tech.
So, you might be wondering, why does tracking these two specific contrasting metrics, vulnerable iron and steel versus active, rigorous inspections, matter so much to a utility's bottom line? Like, why do the investors care? Well, it's because the integrity of this gas delivery infrastructure creates a massive pendulum of financial risks and opportunities that can literally make or break a utility.
The financial risks of bad infrastructure are just staggering. If you have a fatal accident or an explosion, you're looking at massive negligence claims, incredibly costly court battles, and huge fines, not to mention the environmental scrutiny from emissions. But there's a fascinating flip side. Proactively ripping out those vulnerable cast iron pipes actually gives utilities a really lucrative capital investment opportunity. They can factor those safety upgrades directly into their rate base, essentially earning a return on the money they spend, making the whole system safer.
This brings up a pretty wild financial dynamic. Believe it or not, regulated gas utilities often don't incur direct costs for the gas that just leaks away into the sky because the cost of that lost gas is usually passed right on to you, the consumer, baked into your monthly rates. But while we pay for the leaked gas, the utility alone is on the hook for the devastating legal and reputational costs if that leak ignites. So yeah, there is a massive financial incentive for them to actually get those safety inspections done.
All right, to wrap up today's explainer, I want to leave you with a bit of a provocative thought. Now that you know these dual metrics exist, now that you understand the difference between that vulnerable cast iron sitting in the ground and the proactive pressure tests designed to find the flaws, how confident are you in the invisible infrastructure operating right under your own street? Definitely some food for thought the next time you turn on your stove. Thanks so much for diving into this with me today, and I'll catch you in the next explainer.